Welcome everyone to West Explains Best. Today we're going to be talking about trigonometry and area for geometry. So let's go ahead and get started. So in a previous video I talked about how we can find the area of any triangle given a side, an angle, and a side with this formula. 1/2 b times c times sine of the angle, sine of A. So what we need to do first is with any of these triangles, we need to label them. So I'm going to call 6b and 5c. Now it doesn't matter if you call 5b and 6c, it does not. The important thing is the angle in between needs to be called A. So now we're just going to plug in everything that we know. So we have 1/2 times b, 5, times, whoops, I said, you know what I mean, times 6 times 5 times sine 140. And make sure it's in degree mode as you use your calculator. So I'm just going to go ahead and type all this into a calculator. So we have 1/2 times 30, that gives me 15 times sine of 140. So I'm going to go and type in sine, give me a second, sine 140 times 15. And my area is going to be 9.64. What are my units? Inches squared. And that's my answer. Okay, let's go ahead and do another one. Let's go ahead and do 4, just so we get the idea. So we, again, area equals 1/2 b times c times sine of A. Half the battle is just labeling b, c, A. Again, you can change b and c interchangeably. The one thing is, make sure you write side lengths as lowercase letters, and then angles are capital letters, okay? That's important. So we're just going to plug in what we know, 1/2 times b, 7, times c, 4, times sine 96. And we can just go straight across, type this all into our calculator if you have a TI-84 or better, times 7 times 4 times sine of 96. And I got 13.92 rounded to the nearest hundredth. And the units are inches squared. So these problems on the front are pretty straightforward. You'll see that all these talk about an included angle, included angle, included angle. That just means it's in between. So if we have in a case where we're given two sides, let's say this is B and this is C, and we're given two other angles, okay, so we'll call this big C and big B, we would need to find angle A first before proceeding to find the area of the triangle. You would do that by 180 minus C minus B, angle C minus angle B. So that's just a heads up. None of these problems are like that, but you may see that in the future. Now, this is where it gets much more challenging. So we're going to go ahead and start with, we'll do let's do number 9 to start. So in number 9, we're asked to find the area of each regular polygon. So the area of a regular polygon is equal to 1/2 the perimeter times the apothem. The apothem is the distance from a midpoint of one of the sides. Okay, so if we have a side here, keep in mind all these sides are equidistant. Okay, but it's from the midpoint of one of the sides to the center of the regular polygon. This doesn't look exactly centered, so I'm just going to move it over right about there. That looks better. So this would be split into congruent segments, and then if we continued this, you'll see that we can create a triangle. And obviously it's not perfect, but you get the idea. Now we're told that the perimeter is 108, so we have almost everything we need, but we still lack the key thing, which is the apothem, which I drew in red here, and I'm going to label it A. So how do we go about doing this? Well, one thing we can figure out is if there are 9 sides to this shape, and I know because I counted, we can find the length of each side by taking the perimeter divided by the number of sides, and that will tell us a side length. So in this case, it's 108 divided by 9, and that will give me 12. So I know that each side is length 12. Let's do that in blue. 12 miles. So, how does this help me? Well, I want to use anything related to right triangles. Right triangles allows us to use the properties of trigonometry to solve for them. So now that I have a right triangle with my apothem, and that's true, apothems are perpendicular to a side, to the center. Now I need to figure out some of the other measurements. So I'm going to draw an expanded, let me draw this orange line here. I'm going to draw an expanded version of this triangle so you can see it on a little bit easier to see scale. And then the blue. So I only drew half. I'm only interested in half for now because I really don't need anything else in order to do this problem. So I know this orange part is 6. How do I get 6? Because it's half the length of the side. So that's 6. We know that's 90 degrees. This is going to be our missing value. Now we're not told the distance of the blue, which is called the radius. So that's a problem. So we can't use Pythagorean theorem, so we're going to have to use trigonometry. So what can we do? Well, the one thing we can do is we can find our central angle. And that's this unit, this part here. This is our central angle. Okay. Once we find our central angle, it makes this problem much more easy to do. So if you were to draw, what is the central angle? Well, if you were to draw all these triangles, okay, you're going to notice that there are 9 triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 triangles. So if we do 360 divided by 9, that's going to tell us that their central angle. So our central angle is 40 degrees. 360 divided by 9 triangles with that vertex, and that gives us 40 degrees. So that whole distance is 40 degrees. Now we could either use that 40 degrees here, or we could figure out the remaining angles of the triangle. It's up to you. But why don't we just go ahead and use the 40. So the 40 is double that because we took half of that triangle to make a right triangle. So that's 40. So that makes this distance, which is our actual angle that we're interested in, to 20. So we're going to go ahead and use that 20 degrees so we don't have to figure out the other angle. Now, if you wanted to, you could figure out the other angle because we have 90, 20. That's going to make this 70. That's one way to do that. Or I can use the properties of isosceles triangles to figure out that this and this are both 70 because 70 plus 40 need to add up to 180. It's your choice. But we can go ahead and use just the 20 if you want. I just want to erase this. Okay. So now we need to set up a trigonometric ratio using this angle right here, this 20. So let's go ahead and figure out what we have. Well, we have the hypotenuse, which we don't have any information on and we're not really interested in. We have the opposite side and we have the adjacent side. So if we have the opposite and we're looking for the adjacent, we should use the tangent of 20 degrees. So the tangent of any angle is equal to opposite over adjacent. So now we're just going to plug in what we know. We know the opposite equals 6. We know the adjacent is A. Let me change the A to red just so you get the idea. Okay. Now what we're going to do is I like to put this over 1 and then cross multiply to solve for A. So I'm going to get tangent. Let me do it in blue just so you see we did the multiplication, the cross multiplication. Tangent of 20 times A equals 6 times 1, which is just 6. As you can see here, I'm going to need to divide both sides by tangent of 20. Tangent of 20. And I like to do this before actually typing into my calculator. That way I can just type in 6 divided by tangent of 20 all at once. So I'm going to type in 6 divided by tangent 20, and it will give me 16.48 rounded. So now I have my apothem. I know that it is equal to 16.48. Well, now I have everything I need. If we go back up here, I'm going to plug this back into my formula. 16.48 is my apothem. I'm ready to rock and roll. 1/2 times 108 times 16.48, and I get the big reveal. Let's use green. 889.92 miles squared. And that's my final answer. So what are the keys to the rest of these problems? Well, the key is going to be, number 1, finding the length of each side, and you do that by using this formula. Perimeter divided by the number of sides equals the side length. That's going to be your first step. The second step is dividing that side in 2 and creating a right triangle with half that side length right there. Okay, so you have a right triangle. And the next step is finding the central angle. And you find the central angle, I should write it up here. Central angle equals the number, 360 divided by the number of sides. Once you find that, you can divide that by 2 to find your missing angle. So central angle divided by 2 equals the, I guess we'll call it the trig angle, just because that's what we're going to use for the trigonometry. So that will give us our trig angle. Once we have our trig angle, we can go ahead and set up a ratio given this length here and our missing apothem. And in this case, if you use it just like the setup we had before, we know the tangent of our angle is going to be equal to our length over our apothem, and then we just solve for our apothem, multiply by the perimeter, multiply by 1/2, and then we're done. So that's how you approach all these problems. For number 10, real quick sneak peek, you can also use the formula side squared, square root of 3/4. That's for only equilateral triangles, okay? Hope you found this useful. Please leave a comment if you have any questions below. Until next time, be good, be kind, be true, be nice, and be honest. Have a wonderful day.